Hello everyone, my name is Varsha. My team members are Madan, Naveed, and Atya. We are here to present on the material called graphene. Graphene is a single layer of carbon atoms tightly bound in a hexagonal honeycomb lattice. It is an allotrope of carbon in the form of a plain sp2 bonded atoms with a molecular bond length of 0.142 nanometers. The atomic mass of graphene is 12.011 mu. Graphene's exceptional properties, including high strength, flexibility, and conductivity, make it important for a wide range of applications from electronics and energy storage to biomedical devices and structural materials. Its unique combination of properties enables new technologies and improves existing ones. Now, let us look into the synthesis of graphene. Graphene is chemically synthesized through various methods like chemical vapor deposition, oxidation reduction using graphite, mechanical exfoliation, and liquid phase exfoliation. In chemical vapor deposition, this method involves exposing a substrate, which is usually copper, to a mixture of gases containing carbon like methane and hydrogen. And this happens at very high temperatures, around 1000 degrees Celsius. The carbon atoms deposit onto the substrate, forming graphene layers. Oxidation reduction of graphite is a top-down approach and starts with graphite, which is oxidized from graphite oxide. The graphite oxide is then reduced back to graphene, typically using chemical or thermal methods. Mechanical exploitation method involves physically peeling off thin layers of graphene from graphite using an adhesive tape or other mechanical means. Liquid phase exfoliation involves dispersing graphite into a liquid solvent and using shear forces or other techniques to separate the graphite layers into individual graphene sheets. The phase diagram of graphene is very significant. The significance of a graphene phase diagram lies in its ability to reveal the stable phases of graphene under different conditions such as temperature, pressure, etc., and to understand the relationship between those phases. These diagrams are crucial for controlling the synthesis and manipulation of graphene as they guide the selection of conditions needed to specific graphene structures or properties. Why must one choose graphene over other materials? Well, it is because of its exceptional properties like high strength. Graphene is incredibly strong, about 200 times stronger than steel. It has also a very high flexibility. It can be bent and folded without breaking. Graphene is also known for its high conductivity. Graphene is an excellent conductor of electricity and heat. It's also significantly lighter than other materials with similar strength like aluminium. Graphene is almost perfectly transparent, absorbing only 2.3% of visible light, which also talks about its high transparency. Now, let us look into the morphology techniques. Several microscopy and spectroscopic techniques are used to characterize the morphology of graphene, including scanning electron microscopy, transmission electron microscopy, and atomic force microscopy. Additionally, techniques like X-ray diffraction and Raman spectroscopy can provide insights into the structure and quality of graphene samples. Scanning electron microscopy. How does scanning electron microscopy work? Scanning electron microscopy uses a beam of electrons to scan the surface of a sample, and the scattered electrons are detected to form an image. Scanning electron microscopy can be used to visualize the surface morphology of graphene, including wrinkles, folds, and other structural features. Transmission electron microscopy. How does transmission electron microscopy work? Transmission electron microscopy involves passing a beam of electrons through a thin sample, and the transmitted electrons are used to form an image. Transmitted electron microscopy can provide higher resolution images than standard electron microscopy, allowing for the visualization of graphene layers and defects. How does atomic force microscopy work? Atomic force microscopy uses a sharp tip to scan the surface of a sample and measure the forces between the tip and the surface. Atomic force microscopy can be used to image the surface topography of graphene and measure its height and thickness. Now, let us go to the interesting part, nanomaterial synthesis. For the synthesis of graphene, both top-down approach and bottom-up approach methods are used depending on application. Chemical vapor deposition, which we saw previously, is a bottom-up process. In the top-down process, the starting material will often be graphite and bulk carbon. The process is breaking down larger structures into smaller structures, and it may have defects. The scalability in top-down approach is easier for mass production, and the cost is generally lower. Whereas the control over structure in top-down approach is limited. In bottom-up approach, the starting material is carbon precursor. The process involves atomic or molecular load. The quality in bottom up approach will give high purity graphene, whereas the scalability will be challenging for large scale. The cost will be expensive for bottom up approach, whereas the control over structure will be high, precise over the layers. Let's look into the diverse applications of graphene. Graphene can be used to create faster, more efficient transistors and other electronic components in the electronics field. It's used in supercapacitors and batteries, potentially enabling faster charging and longer battery life. Graphene's high surface area and electrical conductivity make it suitable for creating highly sensitive sensors. Graphene can be used to create durable, waterproof, and flexible coatings. Its biocompatibility and high surface area make it useful for drug delivery, tissue engineering, and biosensors. Graphene can be used to reinforce and strengthen materials, making them lighter and stronger. Graphene can be used to create membranes for efficient water purification. I hope you all understand why graphene is very important and why its structure and characteristics are very unique. Thank you.